Hey guys, so today I'm going to be making my own drying agent as I realized after doing some experiments how important it is to have a desiccant on hand. Often, the only way to achieve pure anhydrous substances is by using molecular sieves, calcium chloride, or magnesium sulfate. In this video, I'm going to be showing you how you can make the magnesium sulfate one from Epsom bath salts you can buy at Walmart. So to get started, you want to grab a heat-resistant container, like a porcelain baking bowl that I have here. I insulated it with aluminum foil to minimize heat loss. Then, I dumped in a good amount of the Epsom salt crystals. I placed the bowl on the hot plate and cranked it up to the max, which is, I think, about 400 to 500 degrees Celsius. And after a bit, steam starts coming off of it. Now, Epsom salt is in fact mostly water, precisely 51.2% by mass, and its formal name is magnesium sulfate heptahydrate. This means that for each formula unit, 7 water molecules are incorporated into its crystal structure. However, these bonds are not that strong, and we can easily drive off the water through heating it at high temperatures. This is the principle of a drying agent. When this dry, insoluble powder comes into contact with water, it immediately returns to form its heptahydrate complex, sucking up all the liquid water. The crystals can then be filtered off, leaving us with anhydrous solvent. However, these water molecules don't come off all at once. They come off gradually. When we hit the 150 degrees Celsius mark, one molecule of H2O is driven off, and we are left with a hexahydrate. Surprisingly, it takes about 200 degrees Celsius to decompose the monohydrate and obtain the fully anhydrous form. That's why I pulled out my own blowtorch and blasted the top of the bowl with it. Now, this was when things took a turn for the worse. Suddenly, I heard a loud cracking sound, and I thought nothing of it at first. I mean, this bowl is for baking cupcakes, so it could withstand high temperatures, right? As the powder slowly became an opaque white and hardened, no more water vapor was being released, which means we have achieved its anhydrous form. This was the moment I realized that the bowl had fully cracked. I guess it's not because of the temperature, but maybe the water vapor pressure building up beneath the crystals, as seen here. There is indeed a gap between the magnesium sulfate and the bottom of the bowl, and maybe blasting it with a blowtorch from the top was not a great idea, as the top layer may have hardened and didn't let the vapor escape, leading to this pressure. Anyways, I thought it was gonna be a pain to remove, but the entire thing came out neatly. Finally, I transferred the powder into a mortar and crushed it up into a fine powder. I also did a second batch on a large scale, and after having blowtorched it and left it on the hot plate at max for an hour or so, the plate became literally glowing hot, something I've personally never seen before, and I thought that was pretty cool. And here's the final drying agent, and I transferred everything into a mason jar.